Okay, so nozzles, we have one of the hydraulic structures that we can just use the momentum equation. So let's just see what is the mechanisms and what is like the forces and the pressures applied to the nozzle. As you can see, the nozzle is like some sort of like the decreasing like the pipe, like this kind of like the elements connected to the main pipe. So you can see this is like the main pipe. You can see the firefighters, the hose that they use for firefighters. There's like a lot of pressure behind that one, and the water needs to just exit from the like the very small diameter. That is a very good example of the nozzles. But nozzle, you can imagine in some cases you have the, for example, if you have like a hose and if you're just going to use it for irrigation, the nozzle is another like the application. But nozzle in like the real pipeline system, like the main water distribution system, we might have a like the in larger scale small diameter or a decreasing trend of the diameter as a nozzle. And in this way, if you have like a liquid with a specific like the pressure and the velocity, all the liquid trying to just force the nozzle off the end of the pipe. This because of this kind of like the momentum, the flow is going to just force the nozzle off the end of the pipe. And so it needs to be, so as a result of that, that needs to be connected to the main pipe by using some bolts. These are the bolts and the flange part of the pipe. This is called flange. So the flange needs to be connected by using some bolts, like normally, for example, 3, 4, 5, 6 bolts, for example, depending on the like the nozzle. And so if the force, if you're just going to take out the control volume of this kind of like the water inside the nozzle, you can see here behind the nozzle in control volume, there's a pressure or there is a force which is equal to the P1, A1. This is equal to the force from here. And this is a distribution of the pressure. And from the outside, we have like a P2, A2. And this one, you can imagine that the thrust is towards this way. And that needs to be withstand or resistant by using another force, which is called FR. Now, this is something like the force applies to here, and that it has to be in this direction because it's just going to just transfer the force to the like the not to the bolts actually here. So the FR is shown in the reverse direction in this way. As I discussed before, if you just by mistake just choose the force locked in the reverse direction, you will see the FR will be calculated or the result will be with the negative sign. Anyway, so if you have like this example here for this FR in the left to the left-hand side, so we can just easily calculate the tensile force, that we need to just make sure to design the bolts. Once you can calculate the tensile force, you can pass it on to the structural engineer, or you just going to be as a rule of the structural engineer, can be easily calculate the diameter of the bolt in this case. If you're just going to calculate the force, you need to just divide by the number of the bolts, and then based on the allowable like the stress of the bolt, you can easily calculate the diameter of the force. So here, we're just going to write the momentum equation here with the control volume. The right-hand side is like the positive. So the P1A1 minus P2A2 is left direction, algebraic direction on the force sides, minus FR is equal to rho Q, V2 minus V1. Okay, pay attention. V2 minus V1 does not take from like the direction here. So in this case, like the V2 in this direction, V1 in this direction. So this minus is the difference in the momentum equation. But V1, V2 could be like the positive or negative. But in this case, both of them are positive. Just pay attention. V2 minus V1. And if you rearrange the formula in this case, we're just going to calculate the FR. Before going to do that one, here, these are like the pressure behind inside the like the pipe, the flow. But here outside in the control volume, the P2 is the atmospheric pressure. Atmospheric pressure, we know the atmospheric pressure is 0. So you can just cancel out the P2 or this term, P2A2. If you just remove this P2, we have like the FR is equal to P1A1 minus, you should just kind of rearrange this one, it becomes like a minus rho Q, rho is the density of the water, Q is a flow discharge, inside the bracket the difference of the velocity of the output minus the input. So this is the nozzle.